Let's be real. The world is a messy, unpredictable place, right? From how many customers will walk through the door to what the stock market's going to do next, so much feels like pure random chaos. But what if I told you we could find the secret patterns hidden inside that chaos? What if we could actually tame it and use it to make smarter decisions? Well, that's exactly what we're going to dive into. I mean, this is the million-dollar question for pretty much any business. If everything's so random, how in the world do you plan for it? How do you decide how much inventory to stock or how many people to have on staff? It seems impossible, right? But the world's biggest companies aren't just guessing. They have a powerful mathematical toolkit that helps them do just that. Take Citibank, for instance. Think about all their ATMs. They have thousands of people showing up at all hours of the day. They have no idea when you're specifically going to show up. But what they can do is analyze the patterns over time to predict the probabilities. And that lets them keep the machines full of cash and working properly. They are literally managing randomness every single day. So, how do we start to get a handle on all this randomness? Where do we even begin? Well, the very first step is to find a way to measure it. Before we can spot any patterns, we've got to collect the data. To make this all super clear, we're going to follow a simple example all the way through. Let's talk about a car dealership we'll call DiCarlo Motors. Their daily sales are, all over the map. Some days are great, some days not so much. Our mission is to take this totally unpredictable stream of sales and turn it into a solid, actionable plan. Okay, so before we can do any of the cool math, we need a tool. We need something that can translate these real-world events, like selling a car, into numbers that we can actually crunch. And that awesome tool is called a random variable. Now, it sounds a little fancy, but the idea is actually incredibly simple. We're just going to assign a number to every possible thing that can happen. So for DiCarlo Motors, our random variable, which we'll call X, is just the number of cars they sell in a day. That's it. So X could be 0, it could be 1, it could be 2. You get the idea. And this brings us to a really key distinction. The random variable for our car sales is discrete. Think about it. You can't sell half a car, right? The outcomes are these separate, countable numbers. This is totally different from something like temperature or weight, which are continuous variables because they could be any value in a range. For today, we're sticking to the discrete world of countable things. All right, so now that we can turn outcomes into numbers, we can start to build something really cool. I like to call it a blueprint of possibility. It's basically a map that shows us every single outcome and exactly how likely it is to happen. To build this map, we need some raw material. And for that, we look to the past. DiCarlo Motors checked their records for the last 300 days. And what did they find? Well, on 54 of those days, they sold 0 cars. On 117 days, they sold exactly 1. And so on down the list. This table right here, this is our starting point. Now here's where the magic starts. We take that raw data and we turn it into probabilities. It's super simple. We just take the number of days for each outcome and divide it by the grand total, which is 300 days. So the probability of selling 1 car, that's 117 divided by 300, or 0.39. We do that for every single outcome, and boom, we've just created our probability distribution. And this right here is the absolute heart of it. We've taken a messy, chaotic list of past sales and forged it into a clean, predictive tool. This blueprint, it doesn't tell us what will happen tomorrow, but it does something even more powerful. It tells us what could happen, and it gives us the precise odds for each possibility. Now, a table of numbers is useful, but seeing it, that's a whole different ballgame. When we plot this as a chart, we get an instant feel for the shape of this randomness. You can see at a glance that the tallest bar is right at 1 car sold. That's our most likely outcome. And selling 5 cars, you can see that's super, super rare. Okay, so this map is fantastic. But you can just hear the manager at DiCarlo Motors saying, look, that's great, but just give me one number. What should I plan for on an average day? They need a single, solid number to work with. And that one number is called the expected value. It's so much more than a simple average. It's a weighted average. And what that means is that the more likely outcomes get more weight in the calculation. It's the single best number to represent what we can expect to happen over the long haul. The calculation is actually pretty elegant. All we do is take each outcome, 0 cars, 1 car, 2 cars, and multiply it by its probability. Then we just add all of those results together. We're essentially finding the center of gravity for our entire probability map. So when we crunch the numbers for DiCarlo Motors, we take all those weighted outcomes add them up, and we land on an expected value of 1.50, 1.5. Now hold on, I know what you're thinking. How can you sell half a car? And you're right, you can't. But that misses the point. Over the long run, this average is incredibly powerful. It means DeCarlo can now plan on selling about 45 cars a month. This one number lets them manage their inventory, schedule their staff, and set realistic sales goals. They've taken randomness and made it predictable. So, building these distributions from scratch is a fantastic skill. But what if I told you there's a shortcut? For certain types of really common problems, there's a ready-made tool we can use. Just think about how many situations in life boil down to a simple yes or no. A customer either clicks the ad or they don't. A manufactured part is either defective or it's fine. A medical treatment either works or it doesn't. So many questions are just about these two simple outcomes, success or failure. This incredible shortcut is called the binomial distribution. But it's got some rules. Think of it like a recipe. You need these 4 ingredients for it to work. 1, you have a set number of trials. 2, each trial only has 2 outcomes, success or failure. 3, the chance of success is the same every single time. And 4, the trials are independent. What happens in one doesn't affect the next. Let's look at the Martin clothing store, where any given customer has a 30% chance of buying something. If we look at the next 3 customers, we could map out every single possibility with a tree diagram, like this. You can follow the branches. But imagine trying to do this for 100 customers. It'd be impossible. That's where the binomial formula comes in. It does all this heavy lifting for us, no matter how big the experiment gets. And once you know what to look for, you see this thing everywhere. It's used for quality control on factory lines, for figuring out if a new drug works, for A/B testing in marketing, and even for political polling. It is a fundamental tool for understanding the world. So let's just take a step back for a second and see how far we've come. We started in this world of pure, unpredictable chaos. But by using these incredible tools, random variables, probability distributions, and expected value, we managed to build that structured blueprint of possibility, turning all that uncertainty into something we can actually measure and plan for. We've seen how all this works for selling cars and clothes, but these principles apply to pretty much anything. So the real question I have for you is this. Now that you know how to map uncertainty, what part of your world are you going to try to predict? Thanks for joining me for this explainer.